Alrighty, students, we're going to be talking about this review packet for the finals. This is the review packet that you should have in front of you. And we're going to be working through the circled problems 1 through 32 in the first section. Let me just say a couple words about the final to clarify here before we get on. Looking at this page, this packet is officially due the day of the final. However, if you turn it in by this coming Thursday, it's extra credit. Please prepare well in advance for the final. Do not try to cram this the night before. Please get a good night's sleep before your final. Do not trade off studying for sleeping. Studies show that if you sleep less than 6 hours, your ability to concentrate goes down drastically. You are required to make a 3x5 semester 1 reference card. And you use the information from your reference folder. That's going to help you summarize the basic concepts for the semester. However, if you use the card on your final, it is a 4% deduction. So I collect the cards, I keep them up front during the final. If you choose to use it during the final, it's a 4% deduction on your final. However, keep in mind if you turn in that finals essay early, you get 2 points back. So ultimately, if you do the essay early, it's a 2% deduction. The review packet, each section you're going to get 15 points for showing all your work, 5 points for correcting your work, and then 10 points for the word problem. Most of the word problems we will do in class over the coming week. What to bring for the final? At least 2 pencils, an eraser, colors, highlighters, your filled-in note card, some sort of hydration, either juice or water, healthy snack, and your cell phone and iPods, etc. must be off, away, and zipped up in your backpacks the entire time. Let's go ahead and do these circle problems together. When you're working with algebra, there's a couple basic rules of thumb. When you distribute, you circle and you draw distributive arrows. That's rule number 1. Number 2, you collect like terms on both sides. Collect like terms, both sides. Then you clear, where you bring everything with your variable to one side and all your numbers to the other. So you clear your numbers to one side and your variables to the other. So we're going to follow these 3 steps. Step 1, step 2, step 3. So step 1, we're going to circle and distribute this 8. So circle it, distribute. And that's 8 times 1 is 8. 8 times 10, that's going to be negative 80p plus 4p equals, here we have negative 2p plus, and then we circle this, 8, and distributive arrows. That's 8 times 1 is 8. 8 times 12, that's 16, carry the 1, that's going to be 96p. Now what you want to do is collect like terms. So number 1 we distribute, now we collect. So we come over here, we collect like terms. So I have negative 80p and 4p. And then on this side, I have negative 2p and 96p. So I have 8, and negative 80 plus 4 is going to be negative 76p. And then 96 minus 2 is going to be 94p plus 8. Now we want to clear the variables to one side and the non-variables to the other. So taking a look here, I'm going to minus 8 both sides. And then for this one, I'm going to plus 76 both sides. And this cancels here, and this cancels on this side. 8 minus 8, of course, is 0. 94 plus 76, that's 10, carry the 1, that's 170p. Now you ask yourself, what does the value of p have to be? 170 times what is 0? And the common sense is p is just 0. And that can be a potential answer. Taking a look at number 4. When you're multiplying radicals, keep in mind this basic rule of thumb. Any radical times itself is just the number on the inside. For example, root 5 times root 5 is root 25, but that's a perfect square, so it's just 5. So any radical times itself is just the number on the inside. We do the same thing when we multiply here, is we circle and then distribute. So I'm going to have 4 root 10 plus the square root of 2 times 10. And then you look and you ask yourself, can you add like terms, which mean the radicals are the same, or is there any way to simplify this? So we're going to simplify this down here. Over here, I'm going to bring it to the margin. This one we're going to simplify. I'm going to bring it over here. We have 2 times 2 times 5. And the 2's have a date, so they're going to come out. And so our final answer is going to be 4 root 10 plus, bring that 2 out, 2 root 5. You see if these radicals are the same, if you can add them, and they're not, and so you are done at this point. Sketch a graph of the line. When it comes to grafting lines in standard form, there are 2 ways to do this. And standard form looks like this: ax plus by equals c. That's called standard form. And there's 2 basic ways. Number 1 is to change to y equals mx plus b. You change it, you isolate the y. Another method is to use intercepts. Where that is 0 comma blank and blank comma 0. I'm going to do both. You're allowed to use either method, whatever works best for you. So I'm going to start by using intercepts. Make this nice and big so it's easy to follow. Excuse me, not intercepts. I'm going to change it to y equals mx plus b. So I have here x plus y equals -3. I want to get y by itself, so I circle y, and I tell myself, what do I need to do to get y by itself? Well, for now I need to minus x, and I have y equals -3 minus x. Now, if there was something in front of the y, I would divide that out, whatever it was, but there's nothing there to divide out, so we're actually done except for one little flip around. We want it to look like y equals mx plus b, so we put this first. We have y equals -x minus 3. Now, to use intercepts, we start and we put this here. I'm going to do x plus y equals -3. We start with the idea that if x were 0, what would y be? So go ahead and you kind of put your thumb over x and you ask what would y be, and this one's easy. There's nothing to divide out. Y would be -3. And the other one is if y is 0. So if y were 0, what would x be? In this case, you scratch that out, or you put your thumb over it, and x equals -3. Let's graph both. So over here, y equals mx plus b, we have y equals mx plus b. Our b is negative 3, so minus 3 on the y-axis. And then our slope is going to be negative 1 over 1, so we know it goes down. So I can go up 1 and over 1 to the left, and up 1 over 1 to the left, or I can go down 1 and over 1 to the right. You're going to get the same thing. So to graph this, we're just going to stick a line through it. Now if you use intercepts, our two intercepts are here. 0, negative 3 is our x-intercept. So 0, negative 3 would be right there. And then negative 3, 0 is our y-intercept, and that one's this one right here. And that, using intercepts, you just plot the two intercepts, string a line through it, and you're done. Both work. Moving along to the next page. It says we want to write the slope-intercept form of a line with the two given qualities. So the slope-intercept is y equals mx plus b. So that's our final answer. We want our final answer, whatever it is, to be y equals something x plus or minus something. And we have two qualities. Our qualities are, one, that it goes through a point, this point, negative 5, and is perpendicular to this line. Now, when we're doing with perpendicular and parallel, there's two things you need to remember about slope. When lines are parallel, they have the same tilt. So another way to say this is they have the same slope. So parallel lines, slope equals slope. For perpendicular lines, it's slope times slope equals negative 1. Slope times slope equals negative 1. So we look here, and our given line is y equals negative 5 over 9x plus 4. So we have y equals mx plus b. So our given slope is the m. Our given slope is negative 5 over 9. That's our given slope. So if we go over here to our desired line, we have y equals mx plus b. Our desired slope, we ask ourselves this, negative 5 over 9 times what is negative 1? And it's the opposite reciprocal, which is going to be positive 9 over 5. And for y equals mx plus b, we need a slope, which we already have, and we need the y-intercept, which we don't. So we're going to come up here, and our x-coordinate is negative 5. So for our x-coordinate, we're going to put in negative 5. And our y-coordinate is negative 5. So I plug those in, and then I have my plus b, and I solve. So we go 5 into negative 5 is negative 1, so I end up with negative 5 equals negative 9 plus b. We're going to add 9 both sides. And we end up with b equals negative 5 minus 9 is 4. So our final equation is going to be y equals 9/5 x plus 4. Going back to conditionals, it says write the converse, the inverse, and the contrapositive of the following statements. Now, let's keep track here. We start with your conditional. And a conditional, we just write if P, then Q. That's an if-then statement. Doesn't matter what it is. It's just if something, then something else happens. This is your cause and your effect, hypothesis and conclusion. Converse means to switch. Inverse, negate. Contrapositive, you do both. So converse is going to look like this. If Q, then P. Your inverse, which is the negate, is opposite P, then opposite Q. Contrapositive, you switch and negate. So it's Q, then P, and so it's opposite Q, opposite P. That is your original conditional, converse, inverse, contrapositive. So here we have a conditional, and our conditional says, if we forgive others, then God will forgive you. So if you forgive others, should say you, of course, if you forgive others, then God will forgive you. So our P statement is forgive others, and our Q statement is God forgive you. That's our conditional. So our converse is going to be if Q, then P. So it's going to read like this. You switch. If God forgives you, then you forgive others. So that's the if Q, then P statement. That's called the converse. These two I want you to do on your own. Just make sure they match the order of these two, and then you have one more on your own. We're going to find the midpoint of the segment, the midpoint. Now, to find the middle of anything, it's just average. If you want to find the middle between any two numbers, let's say you have 5 and you have 7, and you want to find what that middle number is, to get that, you simply average these two together. You average. So an averaging is where you add whatever your number you have. In this case, there's going to be 2, and then you divide by that same number. So if you're dealing with two numbers, you add and you divide by 2. That is averaging. So to find the midpoint, because you're dealing with two coordinates, you average the x's and you average the y's. Average the x's. You add the x's, divide by 2, and you add the y's, divide by 2. So here to find the midpoints, you first have to find the coordinates of each of these. And for this one, we are over 1, 2, 3. So we're at -3. And we are down 1, 2, 3. So that's -3, 3. And the one on the right, we are over 1, 2, 3 as well. And we are down 1. So to find the midpoint, we average the x's and we average the y's. So the x's, circle circle, negative 3 plus 3 over 2. The y's, box, box, negative 3 plus negative 1 over 2. Of course, this is 0. Negative 3 plus 3 is 0. 0 over 2 is 0. This is negative 3 plus negative 1 is negative 4 over 2 is negative 2. Now let's plot that and see if it works. So 0, negative 2. 0, negative 2. There it is. And then you ask yourself, does it look like the midpoint? And yes, in this case, it does. So you know you're correct. Number 14 says find the distance between the pairs of points. The distance equation, giant square root. Add the x's squared, excuse me, not add, subtract, I apologize. Hang on. It's x minus x squared plus y minus y squared. Very important when you do this, use what's called a template. Distance is giant square root. Now put that minus sign in there, but leave the x's blank so you could just plug it in. Plug and chug. That will help you not make mistakes with the double negatives. Now let's find our coordinates and see what we can work with here. This one is 1, 2, 3, 3. So it's at negative 3. And up 1, 2, 3, 4, positive 4. And this one, that was negative 3, 4, 5. This coordinate is going to be negative 5. And then, of course, up 1. So now we're going to plug in. Circle the x's. And put an arrow the direction you're going to go. Either way, it doesn't matter. I'm going to go top to bottom. So you draw an arrow. Negative 3 and negative 5. Circle, box your y's, and I'm going to go top to bottom again, 4 and 1. From there, you finish your own math, and then double check your work. Okay, with this one we're finding the slope. And let's write out our basic definition of slopes in the margin. Slope equals rise over run. Rise is up and down. Run is left to right. So slope is rise is going to be the y's, y minus y, over run is going to be the x's, x minus x. Again, to start this, same thing with distance, you make a template. So I'm going to go slope equals something minus something over something minus something. Write that template out. That'll help keep you from dropping the double negatives. Now, let's box the y's, subtract, make an arrow so that you know which direction you're going to go the first time. Negative 12 and 10. Circle the x's, subtract, arrow, left to right. 9 minus 18. You can do your own computations. Follow the same process for the one on the left. It says trace and label the given information carefully. Use 3 different colors as possible to solve for x, and then find the required angle. So we come over here, I'm going to use 3 different colors. We're told that IJT, so I go, is this. So I'm going to use my colors here. IJT, IJT, trace and sweep is going to be x plus 46. IJK is 110. So I, again, J, K, now since it's the whole thing, I'm going to sweep a little bit more on the outside so that I can show the overlap, is 110. And then I have TJK is 76. Put your pencil on T, go to J, go to K, sweep, that's X plus 76. Now it's really important you do a thing equation before you just slam your algebra together. So don't look at the algebra, look at the colors. That's why colors are helpful here. It's really easy to see here that the blue plus the red adds up to the green. So if you use your colors, write it out like this. Blue angle plus the red angle equals the green angle, or whatever three colors you are using. I'm going to pause and let you use your colors to make your equation. Now, circle, plug, chug. So I circle my blue, I circle this, X plus 46, plus, I circle the red, X plus 76 equals, circle the green, circle this green, 110. Now collect like terms, and then clear variables one side and numbers to the other. You can do your own algebra there. (19, 20, 21, 22, 23, and 24), you just match up these vocabularies with the diagram. Please don't cheat on that. Just do your work and then check, please. Taking a look at 26, 25, and 26. When you're working with parallel lines, the key to these, of course, are these four vocabulary words. So make four sets of parallel lines here. So we got four sets of parallel lines with a transversal, or with a stir stick. So step number one, we have alternate interiors, better known as armpits of the Z. That's angle equals angle. Then you have alternate exteriors. And that's also going to be angle equals angle. Then you have corresponding, one's in, one's out, same side. And that's also going to be angle equals angle. Last one, they're both inside and between the lines. These are the only ones that are not angle equals angle. These are called the consecutive, interior, and this is angle plus angle equals 180. You must memorize this. So when you do all of these, your first step is to physically sweep them and ask yourself which one does it match with. So in 26, we sweep, and then we match. So you sweep, and then you match, and then you do your thing equation. So here we take a look at our list here, and we see they are opposite sides of the stir stick outside the line. So they are going to be alternate exterior, which is angle equals angle, So from here, you just circle, plug, chug. Do your own algebra. When you're done finding x, plug it in, find everything you can possibly find. It says find the slope of the line. There's a couple ways to do this. Find any 2 points where there's a direct intersection. For example, there's a direct intersection here at 1, 2, 3. That's going to be 3, 0. Excuse me, 0, 3. I take that back. 0, 3. And then I find another direct intersection, which would be like right here, and that's 1, 2, 3, 4. That's -4, -2. Once you have those 2 direct points, you can use the slope equation, of course, which is y minus y, or x minus x, or you can bunny hop this at a right angle. I'm just going to bunny hop this. This is 1, 2, 3, 4, 5. 1, 2, 3, 4. My rise is 5. My run is 4. Now the only other thing you need to figure out is whether this is a positive or a negative line. It's going up from left to right, so it's positive. So the slope is rise over run. It's going to be 5 over 4 positive. Says you are given an equation in point-slope form. Write the slope-intercept form of the equation of the line. Now, point-slope is this equation, point-slope. Y minus y1 equals slope x minus x1. That's your point-slope equation of a line. You use it when you have a point and a slope. Let's take this equation and put it right underneath what we have. And we want to put it into slope-intercept form, which of course is y equals mx plus b. So the trick to this is simply to get y all by itself. So circle y. And I'm going to start by distributing this 1/2. So my next line reads y minus 1 equals 1/2 x, and then 1/2 of 4 is 2. So we're going to go minus 2. And of course, our last step is this, and you can finish that up and write your y equals mx plus b equation.